Hi, so welcome to the first episode of my new tutorial series. I will try to show you how to program Arduino without the IDE, just using C in terminal. So in this first episode I am going to show you what you will need and show some theory, and in the next episode we will start to do something cool. So here is a list of things you will need. So you need the AVR GCC, the compiler, which you can install from your package manager, and AVR binutils, which is some utilities for working with the executable files the compiler creates. So like this makes the ELF file, and you need utils from this package to create the Intel hex file, which you can then send to the Arduino. You need a make, which is I'm sure you know what it does. It's just a script with instructions how to compile your files into the hex and flash it. So it's like a recipe book for all these utils. And then you need the AVR which is program for the actual flashing. So this guy creates the ELF file. You use these utilities to create a hex file, and then you send the hex file to the Arduino. So yeah, you need all of this, and it's also a good idea to use Linux, or I think it can work on Mac, but for Windows you will need a Cygwin or something like that. Okay, so next slide. How Arduino works. You know that you just like take your laptop with a nice fancy Linux wallpaper, of course, right? You connect it with a USB cable to the Arduino, I don't know, something like that, yeah. Okay, and it just works. So it's actually, there's a bit more going on in the Arduino, but it's not much more complicated. There is a chip which converts the USB to a UART or USART, which is the serial port on the AVR chip, and then this guy communicates with the actual AVR, which is ATmega, usually 328 or something like that. So this is the big picture how it works, and here we have a slide about the bootloader. So as you can see here, this chip converts the USB to a serial port, kind of, and it goes to the AVR chip. So what's going on in there, I will try to show how it works. Here is the AVR chip program memory. Okay, here we have the UART communication, which goes to the processor, and the program memory is divided in two parts. Here one is the bootloader, which is a read-only part of the program memory. Actually, you can write it with serial programming, but we will not do that. So every Arduino has the Arduino bootloader in this section, and actually the AVR chip has a capability to program itself. So when it starts executing the bootloader, which does some magic and actually waits if there's any communication on the serial port, the UART, and if there's anything, it tries to communicate with it, and if it receives instructions like program some bytes into the program memory, then this guy takes the the data it receives and sends it here, so it like writes it. And this is your I think it's called sketch in the Arduino IDE. So this is what's going on. Here is your program, your interrupt vectors, your main function, and all this stuff. So after the bootloader waits 1 second, and if something is going on here, it gives control to your program and it starts doing what you programmed it to do. So this is the bootloader. I hope it was easy to understand. And here we have a slide about the about parts of memory in the Arduino. We have I/O memory, which is a section of memory with like configuration registers and I/O ports and like some parts of the system stuff. And here is the program memory. This is flash. This is RAM. Yeah, and this is also RAM. And yeah, here is your program memory. You can have your instructions like the assembly codes, and you can also have your like constants and string constants and stuff like that. So this is read only, and those are read and write. So here this is the RAM memory as you know it from a computer. This is heap, where is your data like strings and variables and stuff like that. And here is a stack. Stack is used for calling functions and all kinds of things. Actually the C compiler does this for you, so you don't need to worry about stack, but it is here and it goes in the opposite direction. So like the heap grows down and the stack grows up, and if it happens that the heap is too big and collides with the stack, that's not good. So basically you get undefined behavior and the chip grabs out, and I think it will restart. So it just jumps to the beginning and starts executing it from the start and scraps all this content of the memory. So make sure you don't have too deep recursion or bad things like that. Yeah, so I think that's all for this episode, and in the next episode, if I will make it, we will talk about the Makefile, and I will show you how to do your first program. We will try some flashing LED and some really simple stuff. So see you later.